Okay, I said that one last time. I've assigned some textbook pages. They are all with solutions provided. I urge you to go back and take a look at how the solutions have been reached in the book. Be it model drawing, unitary, or the branching method for fraction. Certainly there will be a fraction of a remainder question. I believe so, because in a whole paper, certainly there will be a variety of problems. This is one of the questions we have solved on Tuesday. I'll say it's quite a common question also. So I wrote down the pages on the board. I say once more, I'm not asking you to do more practices or more work, but I seriously urge you to go back and study your textbook. Take a look at and refresh your memory on the methods for changing ratios and for percentage. Okay? Clear? Right, let's get going. Starting from the last question here. This is a common PSLE question. You realize that it's familiar because actually the shape doesn't matter. So, I hope you have annotated for here, we have Ming having 3 circles to form this figure here. Now, there are 3 circles. I can help myself to have a bit of an idea by drawing out the 3 circles. Small, medium, large. The small one is the one that is shaded. The medium one is the white one, and the large one is shaded as well. The ratios of the areas of these circles is 1:4:6. 1:4:16. The areas of the circle in the ratio of 1:4:16. She shaded some parts of the figure as shown. What is fraction of the figure was shaded? Now, it's asking for the shaded. If we are looking at the whole figure, we are talking about the biggest circle here. The biggest circle will be the whole figure's base. So I can say that the whole figure, this whole thing, the whole fraction of the whole figure shall be 16 units. Now, then I have to find out the shaded parts, meaning I need to cut away the white part. But the white part is a bit confusing also, because the white part has the small circle inside. So, to find the white part here, is using the middle circle minus the small circle. This will give you that white unshaded part. So it's this white part here. So that will be 3, correct. 4 units minus 1 unit. So that's 3 units. So in other words, the whole is 16 units minus the 3 units. There will be 13 out of 16. That's all. Don't need any area knowledge. It's about being able to visualize the overlap. So the white part is 3 units. Huh? Simplify 13 to over 16, how to simplify? Can you understand? Now, even if I say I take the big circle, okay, I minus the middle circle, right? That is 16 minus 4, that is 12. That is, I cut away the big circle. But then I must add back that black small circle. So that's 12 plus 1 is still 13. So 16 is the whole, is the big circle. So there's no need to use any square root numbers here. Okay? It's basically understanding parts and whole. Alright? Okay, moving on. I start from the beginning instead. Here. In this question here, why I say annotation is important? Oh wait, what does this represent? No, this. The word this. Yes, you said it's 9,000, but more importantly, this is August. Thank you. This is August, and August was an increase from the number in July. Can you see why I wrote there OG? Original. So if July is the original, what is the percentage? So original is the 100%. So 20% increase, we are looking at August. August has a 20% increase. So August should be how many percent? 120%. That's right. So August is 120%. We are talking about 120% is equivalent to 9,000. So you want to find what's 100%. So it will be 9,000 divided by 120 times 100. Is that okay? 9,000 divided by 120 times 100. 7,500. What is the common mistake? The common mistake is a lot of people go and write 100% is 9,000. How many of you wrote 100% is 9,000? That's where the mistake is. How to treat that mistake? Please do your annotation. You wrote 100% as 9,000 because you think that August is the original. But no, the increase from the number in July. So July is the original. So the original 100% should be July. In other words, August is 120%. You need to get this right. Start off with being very clear what is the original, who's the original. Next question. The straws of 3 colors. 1/4 of straws were blue. This is a fraction. 1/4 of the straws were blue. What is the numerator representing? Danson? 1/4 of the straws are blue. So the numerator refers to blue. Thank you. And then the denominator stands for total all the straws. So I have the next sentence. The ratio of the number of red straws to the green straws is 2:3. So red is to green is 2:3. Now, here's the problem. The problem says the bag contains straws of 3 colors. So there are only 3 colors. The 3 colors are blue, red, and green. The ratio that is given here is blue is to total, that is 1:4. How many of you wrote here blue is to green is 1:3? That's 0 marks. Let's look at it again. The ratio here is blue is to total. Tell me, red and green together, how many units already? 5 units. Then how can there be the total be 4 units? Can you understand that? So if red and green together is already 5 units. If I look at this, 1/4 is blue versus total. Then what is 3/4? 4 is still total. What is 3? 3 is red and green. So red and green will be 3 units because the total is 4. The total is 4 units, blue is 1 unit, red and green together must be 3 units because 3/4 are the rest. Now, but then here says red and green is 5 units. Then how? Find what? Times what? To find the equivalent fractions. To match these 5 units together with the 3 here. Is it matching now? It's not matching now. So, here become 15. Here also become 15. So, yes, I find the equivalent fraction. Total become 20 units. Blue become 5 units. Red and green, 15. So times 3, times 3, times 3 to find the equivalent ratio. So now I match red and green, match red and green. Then I can use the correct ratio. Blue is to green will be 5:9. If I have to draw this model out, I have 1 whole and I have 1/4. This 1/4 will be blue. These 3 units remaining should be red and green. But these 3 units, how can be 5 units? Cannot be. So I have to cut. I cut each of the 3 units into 5 parts so that red and green can become 15 parts. So in other words, my blue also have 5 parts. Can you understand what I'm saying? Sorry? Sorry, what are you saying? There's a camera delay. Oh, sorry. Is this okay? Now, next one. Just now I already gave a clue when I was talking to Ryan. There are two people here, Ben and Chandra. Ben, Chandra, and then there's ratio. So the first thing I talk to you about fraction and ratio is to write down first person, second person, quantity 1, quantity 2, sum and difference. And then we want to ask ourselves what's the change. Here says, each of them, both Ben and Chandra, they bought a shirt at the same price. Now, considering both of them bought the shirt the same price, let's look at it. Ben started out with $90. He bought a shirt. Will that be changed? Huh? Yes, he will. He bought a shirt and then he minus the shirt. Definitely there's a change. Now, then Chandra. Chandra, did he buy the shirt? He also bought the shirt. Are the shirt the same? Yes, the shirt is the change. So Chandra also changed. Both of them changed. Let's look at the sum. If I put Ben and Chandra together, did their amount of money change at the end? Yes, still change because both of them spend money, correct? So both their money will drop because they bought and spent money. Then let's talk about the difference here. Both of them spent the same amount of money. What tells you about the difference? Same. No change. So I said this before. Answer has $10, Giselle has $8. Between the two of them, difference is 2. If I take away $5 from both of them, Ansel will have $5 left, Giselle will have $3 left. The total amount of money they have changed, but the difference between two of them still $2. Can you understand that? So once you find out what is not changing, that is the clue. In other words, if you think about it this way, if I draw a model, Ben had more money, Chandra had less money. Ben is $90, Chandra is $48. Now both of them cut some money away. This sum money is the same amount. Didn't change. But after that, this one here, Ben's money and Chandra money, Ben become 4 units and Chandra is 1 unit. So I say one more time the example, you think about it. Answer at the start, he has $10. Giselle as the start as $8. Together they are $18. The difference is $2. If I take money away from them, minus 5, minus 5. Answer end up $5. Giselle end up $3. Their total amount of money definitely dropped because I took the money away from them. But the difference between them, this was 10 minus 8, it is 5 minus 3, the difference is still $2. Can you understand this? Now, so in other words, their difference is 3 units. And that difference in 3 units is $90 minus $48. Yes, which is $42. So 3 units is $42. 1 unit is 14. So can you find the shirt already? So it's 48 minus $14. The shirt is $34. This is for Chandra's case. Okay? Last question. Last question, percentage question. This one I say considerably easy. Because the male is 50, the female is 70, the first percentage that is shared is about the male members. The second percentage that is shared is about the female members. So the percentages are not really overlapping each other. So I can calculate the male students by using the 16% times the 50 males, and then the female students being 10% times 70. I'll get the numbers. Eight and 7. So percentage of all the members are students. Students, all members. 8 plus 7 over 50 plus 70. And then you want a percentage, so times 100%. $15 out of 120 times 100%. 12.5. Okay, now may I know